picture this, a tiny little device.
Yeah.
Something that could practically sit in your lap.
Mm-hmm.
Doing something absolutely incredible.
Okay.
Not here on Earth,
Yeah.
but hundreds of millions of miles away on Mars.
Wow.
We're diving deep into the story of NASA's Ingenuity helicopter today.
Okay, so Ingenuity.
Yeah.
It started as a very focused technology demonstration,
Mm-hmm.
sort of tagging along with the Perseverance rover.
Right.
So imagine like this tiny helicopter,
Okay.
just 680 grams,
Oh, wow.
lighter than a standard laptop even.
That's incredible.
Built with surprisingly accessible technology too.
Really?
Yeah, you'd find similar components inside your Android smartphone.
Oh, wow.
Or even like the battery from a cordless drill.
Interesting.
This really challenged how we traditionally think about spacecraft.
Okay.
Usually they rely on expensive radiation-hardened space-grade components.
Right.
But Ingenuity showed us we could develop missions faster and cheaper.
Yeah, it almost sounds too simple for a trip to another planet. At first, the plan was just for a few test flights.
Yeah.
Just 30 days.
A proof of concept.
Right, a proof of concept.
But what happened next?
Yeah.
It was astonishing.
Totally.
Ingenuity just kept flying
Yeah.
for over 427 days.
That's amazing.
It's a testament to its resilience.
Right.
This underdog story playing out on another world.
Yeah. Today,
Mhm.
we're going to try to understand how this little machine defied all expectations
Yeah,
and what lessons we can learn from it.
absolutely.
So let's get into it.
Let's do it. Yeah.
One of the first things, it must have been so hard to convince people that Ingenuity was actually worth it.
Oh, yeah, there was definitely,
Some skepticism.
compared to everything else Perseverance was set out to do.
Absolutely. The rover's scientific goals were the priority.
Right.
I mean, understandably.
Of course.
So yeah, some people question why dedicate resources to this experimental aircraft.
Exactly.
Yeah.
And the budget.
$80 million for Ingenuity,
Right.
which is a lot.
It is.
But it's less than it costs to make the movie The Martian.
That's right. That's a great point.
So that kind of limited funding
Absolutely.
must have really pushed the team to be creative.
Precisely. They had to be incredibly resourceful.
Yeah.
I mean, using consumer electronics for a drone on another planet
Right.
that wasn't just about saving money.
Yeah.
It was a bold move.
Totally.
This highlights how limitations can actually spark innovation.
Yeah. And thinking about trying to fly on Mars
Yeah.
in the first place,
Right.
the atmosphere there is so thin.
It's about 1% as thick as Earth's.
So it's like trying to fly a helicopter
Mm-hmm.
with 99% less air.
It's a huge challenge.
Right. How did they even start to figure that out?
So that thin atmosphere
Uh-huh.
really forced them to make some different design choices. That's several times faster than a typical helicopter here.
Yeah.
And the whole structure had to be super lightweight.
I bet.
Yeah, they scrutinized every gram.
To make sure it could actually lift off.
Exactly.
And then, of course, that incredible moment.
Yeah.
Sol 58.
Right.
The very first controlled, powered flight.
On another planet.
And on another planet.
It's like the Wright brothers all over again.
Isn't it?
It really is.
Like a Kitty Hawk moment.
120 years later.
But on Mars.
Let's
It's not
squirrel.
just about flying.
Right.
It's about proving it's even possible.
In such a different environment.
So they proved it could fly.
They did.
But then the mission took this really interesting turn.
It did.
It wasn't just a demo anymore.
Right.
It became a real tool.
It transitioned into a valuable scout.
Yeah, like an aerial scout.
To guide-
Suddenly this little helicopter
Yeah.
had a real purpose.
Working alongside Perseverance.
So what kind of tasks was it doing?
Well, it was crucial for mapping safe routes.
For Perseverance.
For Perseverance, exactly.
Okay.
Imagine having a drone's eye view of Mars,
That's amazing.
so it could identify hazards like big rocks or steep slopes,
Wow.
and that helped the rover team plan the safest paths.
It makes so much sense.
But it did more than just scout.
What else?
It mapped areas that were too risky for the rover,
Okay.
or places Perseverance couldn't even reach.
So it was gathering all this extra information, flying into uncharted territory on another planet.
Yeah.
That must have been nerve-wracking.
It was definitely risky.
And with that communication delay,
Right.
you couldn't just control it in real time.
No.
How long was the delay?
Over 6 minutes each way.
So you send a command,
Yeah.
and 6 minutes later,
You find out what happened.
wow, so no joystick piloting.
No, Ingenuity had to be autonomous.
So it was making its own decisions.
It had pre-programmed flight plans,
Okay.
and it used its sensors
Wow.
to figure out what to do.
That sounds so risky,
Yep.
especially since you can't test it out in every spot beforehand.
That's right.
So no GPS on Mars?
No.
How did it know where to go?
They used a system called visual odometry.
Okay.
So it has this downward-facing camera,
Okay.
black and white high-res,
And it takes
30 pictures every second.
30 pictures every second.
Yeah, it's a lot of data.
Wow.
It uses those images to track its movement.
Relative to the ground.
Yes, exactly like an optical mouse on a mouse pad.
That's so clever.
By looking at tiny changes in those images, Ingenuity could figure out how far it moved.
And in what direction?
In what direction, yeah.
But there was that issue on Flight 6.
Oh, yeah. Flight 6, I remember
that.
reading about that.
That was a tense moment.
What happened?
There was a software problem.
Oh, no.
The camera images and the data from the IMU weren't syncing.
What's the IMU?
The inertial measurement unit.
Okay.
It's a set of sensors
Okay.
that measure things like acceleration and rotation.
So important for staying stable.
Absolutely crucial. Okay, so they weren't syncing.
Right.
What did that mean?
The navigation system was getting bad data.
About its position.
Exactly.
That's not good.
No, it caused Ingenuity to start oscillating.
Oscillated.
Yeah, like wobbling in the air.
Oh, no.
It could have easily crashed.
Wow.
Luckily, the engineers back on Earth figured out the problem.
What did they do?
They sent a software update.
A software update.
Yeah, millions of miles away.
They saved the mission.
They did. It was remarkable.
That's incredible.
And all that while dealing with the Martian environment,
Right.
which is not easy.
Not at all.
Mars is a harsh place.
What were some of the biggest challenges?
The cold was a big one.
How cold?
Martian nights can get down to negative 133 degrees Celsius.
That's unbelievably cold.
That could damage the batteries
Oh, yeah.
or even cause the soldered connections to crack.
Wow.
And then there's the dust storms.
Right. I was just thinking about those.
The dust is a problem for a couple reasons.
Okay.
First, it settles on the solar panels.
So they can't generate as much power.
Exactly. There was one storm that reduced power by 18%.
Wow. And second.
The dust can get into the moving parts.
Like the rotors.
Yeah, potentially jamming them.
So it's amazing it lasted as long as it did.
It really is.
But then there was that time when you lost contact.
Oh, yeah. Around day 427 days.
That was a worrying time.
It must have been so stressful.
We thought it might be the battery.
Dead.
Possibly, yeah. The dust might have blocked the solar panels.
Okay.
Or there was a chance the onboard clock had reset.
So how'd you get back in touch?
We had to recalculate when Ingenuity would wake up.
Based on the sunlight.
Exactly.
That's impressive.
We monitored during those times.
Eventually.
We got a signal.
That's so great.
But we also learned that the inclinometer had failed.
The inclinometer?
Yeah, it's a sensor that tells you the helicopter's orientation.
So that's pretty important.
It is.
You can't exactly send a replacement part to Mars.
No, we had to improvise.
So what did you do? We took the IMU from a Google Pixel 3 smartphone.
A Pixel 3.
That was already part of Ingenuity.
You're kidding.
We wrote new software to use the phone's sensors.
It's a replacement.
Yeah, it was a real MacGyver moment.
That's brilliant.
It was a great save.
It's incredible that those everyday components
Yeah,
could survive on Mars.
it really is.
Under all that radiation and the extreme
It
temperatures.
challenges what we think we know.
About space-grade hardware.
Exactly.
Maybe future missions could use more off-the-shelf parts.
It's a possibility.
That would be amazing.
It would make missions much cheaper.
And faster to develop.
Exactly.
And as Ingenuity kept going,
Mm-hmm.
it wasn't just surviving, it was
No.
getting better.
We were able to push it further.
How so?
Well, the altitude increased
From what to what?
from 10 meters, 24 meters,
Wow.
and it got faster, 10 meters per second,
It was breaking its own records.
for distance and flight time.
That's amazing.
But eventually it came to an end.
yeah, the crash.
Right.
What happened?
On Flight 71,
Okay.
Ingenuity flew over a sand dune.
Okay.
It was a pretty featureless area.
Featureless
Yeah, the navigation system needs to see things on the ground.
to track its movement.
Exactly.
It's
Without those features,
yeah.
it struggled to figure out its position.
Oh.
It made a hard landing.
But it survived.
It did.
So what about Flight 72?
We tried to move it to a better location,
Okay.
but it encountered another featureless area.
And
This time the navigation errors were worse.
so it crashed.
It did.
I read that the impact caused something called precession torque.
That's right.
Can you explain that?
So precession torque,
Yeah.
it's a force that acts sideways.
Sideways.
Yeah, like perpendicular to the applied force
Okay.
and the axis of rotation.
So in this case,
It put a lot of stress on the rotors.
when it hit the ground,
Exactly.
and that caused them to break.
The carbon fiber blades snapped.
At their weakest points.
Right.
A Mars air crash investigation.
It's a first.
That's crazy.
We analyzed all the data.
To understand what happened.
Yeah, it was really important.
For future missions.
We learned so much.
So even though Ingenuity is gone, its legacy lives on.
It does.
Especially with this new project.
Chopper.
Yeah, what can you tell us about that?
So Chopper is the next generation Mars helicopter.
That's so cool.
It's going to be much more capable.
In what ways?
It'll have 6 rotor blades.
Okay.
For more stability.
So it can handle harder landings.
Exactly.
Wow.
And it'll operate independently.
From rovers.
Yeah, it'll communicate directly with spacecraft in orbit.
That's a big change.
It is.
And the payload capacity?
5 kilograms.
5 kilos.
That means it can carry scientific instruments.
Wow. So it can do its own science missions.
That's the goal.
That's incredible.
It opens up so many possibilities.
Ingenuity was the first step.
It was.
And now Chopper.
The next phase.
It's almost poetic.
How did you...
Ingenuity, this little project that people doubted. Now it's the symbol of human ingenuity.
It's true.
Sitting silently on Mars.
It's still sending some data back.
Really?
Basic environmental readings.
Wow.
And it's carrying a piece of the right flyer.
No way.
Yeah, attached beneath the solar panel.
That's amazing.
Connecting the first flight on Earth to the first on Mars.
This whole story is so inspiring.
It really is.
From a long shot project to a whole new era of exploration.
It's about resilience, innovation,
pushing boundaries,
challenging what's possible.
And it all started with this little helicopter that refused to give up.
Ingenuity by name.
And ingenuity by nature.
That's a good way to put it.
It makes you wonder.
What else is possible?
What other challenges could we overcome?
If we just think differently.
If we embrace these underdog approaches.
Exactly.
It's a powerful thought.
It is.
And it leaves me feeling so excited for the future of Martian exploration.
Absolutely.
Thanks to this incredible little machine.
To ingenuity.